Happy Friday, everybody.
Happy Friday.
So today we have a very special lecture. This is our invited industry speaker, James.Walker. So James is actually, you can't tell just by looking at him, but he's quite a gifted person. So he took my software engineering class. He had good training. I supervised his third year project and his master's project. I wish I had supervised his PhD. I jointly supervised his PhD. And now he works at a company called CA, which used to be Grid Tools. And because they said, we want you to work here and we can't live without you and we're going to pay you lots of money. So please work for us. So James said, okay, I guess I'll work for you guys. So every year we do have an invited industry speaker, and CA.com is the name of the company, has sponsored prizes for the software engineering module for the group assignment 5, which we'll announce at the end of the lecture. Yep. So I guess I'll stop rambling now and let James take over.
Thanks. Yep. Okay, so today I'm going to be talking about kind of software development in industry. So the company I work for, CA Technologies, we're kind of creating software for software development. Okay, and this is going to be kind of about how we can produce high quality software in industry. So Bob kind of went over a lot of this, but I was just going to give a brief little introduction to myself. So I was at Swansea University before. Predominantly my research was into data visualization and big data problems. I joined Grid Tools as a software engineer working part-time, and then we got acquired by CA about a year ago now, and I'm the lead developer and manager of the team who are based in Oxford. We developed one of the products. Okay, so firstly, I'm going to go over kind of a little bit of background into software development, probably a lot of the stuff you've seen before in Bob's module. And then I'm going to give an introduction to model-based testing. Thirdly, we're going to take a look at one of the products CA produces, which is Agile Designer. But this is kind of based around model-based testing, okay? So it's not, a sales pitch or anything. Any kind of tool which is model-based testing, does this kind of functionality, okay? So let's just take a look at a bit of background first before we get underway, okay? So a lot of you are probably already familiar with the software development lifecycle, right? So you start with kind of requirements and analysis. So a business analyst or a product manager would typically, come up with some requirements for a system, okay? A design team would then pick this up and say, okay, what's the requirement going to look like in reality? An implementation team or software developers would come in, pick up the design and transform the design and requirements into, an actual product. The testers would then pick up the implementation and make sure the implementation matches the design and requirements, okay? So one of the kind of very early or traditional ways of creating software was to use the Waterfall Model, okay, where, you start with your requirements, you go through design, implementation, and then you test, and then you release the product, right? Now, this is kind of a one-time process, so you only do this once. However, I'm sure a lot of you have found that during your own software development, or probably even the project you've done in this course, that this really doesn't happen. You'll go back, you'll think, oh, I'll add in this new feature. So you would go back through to requirements and you would do the whole process again, right? So in actual fact, this is called Agile Delivery or continuous delivery, okay? Where you have lots of mini waterfall models. So each sprint or iteration of the software, okay? So you go through your software development lifecycle, you release the product, and then you go through it again and you go through it again, right? So each time, we're giving out a piece of software to the customer, right? And the idea here is that, this is adaptive to change. If the user requirements change or we need to add in a new feature, we can add that into the next iteration and go through, etc., right? Okay, so that was kind of my quick little background and a little bit of definitions I wanted to go through. So now just to go through some kind of traditional testing techniques. So there's lots of different types of testing, right? So functional testing, unit testing, user acceptance testing, there's a whole bunch of stuff going on here, okay? And each of these are kind of executed at different stages in the software development lifecycle, okay? Now, traditionally, this is done through manual testing. And a manual test, basically, we define a set of steps or a test case. So if we imagine a login screen, step one, we might enter a valid username. We'll then enter a valid password. And then finally, we'll click login, right? And for each of those stages, we have an expected result. Okay, now this is fairly simple. Anyone can pick this up. They understand the test case. They understand how it needs to be executed, right? But the problem here is that you can imagine if we create lots of test cases for this login screen, they'll all be very similar, right? And what happens when, the login screen changes, right? I have to go back through each of my test cases, have to update them. It's a very difficult and time-consuming process. And also executing these is very difficult as well. So, say I've got 100 test cases, perhaps each one of these would take me a few minutes. Easily, I'm going into a couple of days' work there just to test one very simple, bit of functionality. So this is where automated testing comes in, okay? And basically with automated testing, we're going to take, our manual test steps we have before, and we're going to automate these, okay? So we're going to make the computer run this test case for us. So we write an automation script, which is, in a kind of automation language, so Selenium, Reconnect, etc. These are all kind of common automation languages. So like you guys would write software in C++, you can write an automated test case in these languages, right? And then you would execute the test case and it would deploy it on, Chrome, Windows, Mac, whatever you're going to test your system on, okay? So let's just take a look and see what an automated test case would look like. Okay, so this is in Selenium, okay, and this is testing a login screen as before, okay, and so firstly we're going to enter a valid username, okay, so we're going to the browser, we're saying find an element, which is the input ID, and we're sending some keys to this input, right, so my login here, James.Walker at ca.com, okay, we're then doing the same with entering a valid password, okay, and then finally, we're going to click the login element, .click here, okay? And then fourthly, we're just going to check to see that, we've logged in successfully, okay? Now, this is completely reusable. So once I've written one of these test cases, I can go away, I can execute this on, a build machine, perhaps after I've compiled my source code. It can go away, run these test cases, and it's very quick to execute these, right? So it's much quicker than manual testing. Okay, there's no kind of human error can't come into this. It's strict. We've written this in code. Okay, but you still get the same problems, right? So you end up with lots of similar scripts. Okay, it's very difficult to find people who know how to write this code. And what happens when the system changes again? Okay, we've still got to go through all of this code and manually add steps in or change the code, right? So there's still some effort there when the system changes, which, as we know, happens a lot in Agile and continuous delivery, okay? So just kind of a graphical representation of what I'm talking about here, okay? So traditional automated testing, okay? We're going to imagine that this projector is the software we're testing, right? Okay? And it's mapping a triangle here. So with manual testing, okay, or automated testing, the automator is going to create the scripts which match the system, right? So we're going to create some scripts which test that this triangle is created on the screen. Okay, so we're going to go through and cover all the behavior of this triangle. Okay, now what happens when the system changes? You see we've got a hexagon here, okay, and you'll see our test cases no longer match the triangle, right? So all of these test cases are no longer relevant, they don't work, they don't test the behavior that we want to make sure is happening. So this is where model-based tests is a new concept which has just kind of come through research. It's making its way into industry. It's starting to be used by a lot of companies out there at the moment. Okay. Now, with model-based testing, what we're going to do is we're going to create a model of the system, and we're going to say this is what the system should do. Okay. And we're going to test the system against a model, right? So we're going to test the two together. And then are they the same? Does the system do what the model was meant to do? Now, when I say a model, okay, I'm kind of talking about a flow chart here or a state machine, but we're just going to talk about flow charts, okay? And they're nice and intuitive. Anyone can kind of pick these up and read them, right? So we're going to have a start and an end point. This is a bit blurry, but basically what we have here is a bunch of processes and decisions, okay? So if I just take a look at this in the tool, maybe it'll come up a bit more clearer. So this is just like a little simple kind of abstract flow that we usually start off by showing people, which is how to make tea, right? So you would start off and you would say, do I have water? Yes, I do. Do I have tea? Do they want milk? Do I have milk? Would you like sugar? Do I have sugar? And then you either end up at an end point where you can either make tea or you don't make tea, right? Okay, so these are our kind of two end states. As I say, this is abstract, but the same kind of principles apply to, software. You can imagine that if I'm logging in, have I entered the correct login details? Have I entered the correct password details? Click the login screen, and either I end up authenticated or not authenticated, right? Okay. Good. Okay, so yeah, each process defines the state of the system with transitions to other states through decisions and actions, right? Now, how do we extract test cases from this model? Okay, well, what we're going to say is that each path through this model is going to represent a test case, okay? And what we can do is we can, extract all the possible routes through this model, and we can say this is an exhaustive test of our system. Now, often for complicated systems, the number of all possible routes for a system is infinite, right? We could end up with trillions and billions of possible routes for a system. So what we have is a bunch of kind of optimization techniques. I'm not going to go into these in much detail, but basically you can choose what kind of coverage to test your system at, okay? So you can say I want to cover every node in the system, every edge in the system, kind of every decision, right, or every kind of user action. Or even kind of the most probable routes through the system I want to test, okay? So just to kind of revisit our visual model here, okay? So we've got the bottom projector, which is our system, okay, projecting this triangle. Now, in the top left, the red one is going to represent our model, okay? So what we're going to do is we're going to create a model of our system, okay? The model is saying that our projector should project a triangle, okay? And the projector is projecting our triangle, okay? So the system changes again, and we're no longer drawing a triangle, we're drawing a hexagon, okay? And all we're going to do is update our model, right? So we're going to say our model should no longer represent a triangle, it should represent a hexagon, which is what the underlying system is doing. Okay, good. So I'm just going to move on to kind of a little demonstration of this in practice, okay? So if I just load up Chrome. Sorry, it's going to work again. just while we're waiting, does anyone have any kind of questions so far? Yeah.
I have a question. If I guess the question, so to speak, is how is updating the model different from just updating the script example that you showed earlier? You know what I mean?
So, I mean, in reality, if I just go back to the example here, just go up. Okay, so in terms of the scripts here, right? So in reality, I can have thousands of these scripts, okay? Which often you find, sometimes, you know, there's tens of thousands of these because they execute so quickly. And, you know, if I change some of the GUI, for instance, to say I update the name of the input ID for the username, or I add a new field in my login form. So now I've got to go through all of these scripts. I've got to look at them manually, and I've got to say, okay, is this script affected by my change? If it is, I've got to go into the script and add in my new field or change the script. Okay, so I'm going to end up doing this thousands of times, which is obviously very, very difficult. And often there's just not enough time to do that, right? So what often happens is that companies invest a lot of time creating these scripts, okay? And then a change happens in the system, and either they look at it and they say, right, we need to invest a lot of money here and update our scripts, or they either say, B, let's just scrap it all because we don't have the resources we need to update these automated test cases. So they just end up starting over and repeating the whole process again, which is obviously, you know, a very expensive process, right, to be able to do that. Oh.
I guess so, yeah.
You don't look very
well, I guess to me it looks like, I mean, with the script example, you could say, okay, we want an object that's just the login with all the scripts concerned, like organized by the login. And so we could constrain the search of the scripts to just the login object rather than a linear search.
That only works so far, right? So you could create a mapping of kind of, okay, I could have an object which says call my username field, right? And that object is going to have kind of a map of all of the fields to field names, right? But the problem is that I still have to construct my test case in an iterative way. So whatever way I look at it, it always gets decomposed into these steps, right? Now, the problem is I can't tell the system how to create these steps for me. I have to manually do these myself. So I would always end up with a process where I have to go back and add in an extra step if there needs to be, or if the logic changes, I need to go in and deconstruct this somehow, right?
So the model process is somehow automating.
It's automating the automation.
Okay.
Which, you know, is a bit of a, it's a bit of a difficult thing to explain, but hopefully, you know, when I show you it in a tool, it'll make more sense, right? Okay, so I'll just skip back down here to where it was. And I'm going to load up a little registration page we created. Okay, so this is just a web app, basically.
Hey, can you guys quiet down?
Okay, so we've got a login page here. We can enter a username and password. So if I enter some incorrect details here and click login, it's going to come back saying the username or password is incorrect, right? Now, I can go in and I can register here, and it's going to ask me for some details. I'm just going to enter in register a new user. I'll click register, and it's come back saying the registration is successful, right? So I can go in now, I can log in using this new login I've created. It's going to take a couple of seconds. Work. It's always good when a live
need to test it more.
Yeah.
I was just thinking, oh, we never do live demos in class, but actually we do in this class quite a bit.
Okay, well, something's gone wrong there, but we can carry on anyway. So basically, I've entered in the correct details here. I click login, and it would just take me through to a kind of administration page where I can, add or delete users, right? Okay. So what I've done here is I've created kind of a little model of this user registration page. I'm going to zoom in quite a bit, I think. Is that readable? Okay, good. Right, so I start off my starting point. I load the web page. I can either click on the register link or I can click on the login link, right? Now, if I choose to log in, I can enter, either a valid, an invalid username, or I'm not going to enter a username at all. So these are my three options. I could decompose these into more if I wanted to, but we're just going to stick to these three for this example. Okay, I've got my password field where I enter either a valid password, an invalid password, or no password at all. And then I'm going to go ahead, click the login form where it will take me to the administration page. I can delete the user or log out. And then after I've logged out, I can either go back through this process again, right, where I load the web page, I can register, I can log in again. So if I register, here are my details I can enter. So the first name, the last name, the username, and then the password as well, right? Okay, so this represents my model of all the different actions I can do on this user registration page. Okay, we then have, sorry, the screen resolution is not great. We then have this Path Explorer, okay, so I can go in and I can create my test cases, so I can say cover kind of all the process blocks, and it's going to give me all of the test cases to cover those blocks, right? I can go through, I can say generate me all possible paths, and it's going to come back saying there's 1,576 possible routes through this system, okay, of logging in, not logging in, registering, not registering, okay? So even through that very simple and abstract example, you can see that, there's a lot of possible combinations the user can undertake, right? And this is why, a lot of bugs go through into defects, because in reality, with real systems, you're looking at this number being in the billions and trillions, and it's not possible to test this amount, right? Okay, so, I can go away, I can click this, and it will compute me 1,600 of test cases instantly, okay? Now, what's going on in the background here and how we can create our automation is that there's a configuration in here, which is in an automation panel, okay? And what we have here is a bunch of objects. So if I take a look at, say, an element object, there's a bunch of actions which can be associated with an element. And I've created this myself. This is based on the Selenium language, which you can go away and take a look at yourself. And that's an open source language for automation testing, okay? And what I've done is I've just associated a bit of code to that particular action. So if I look at click link by CSS, you'll see here that we're saying get an element by CSS. This is a variable, okay? And then we're saying at the end the dot click to click this link, right? So this code is going to click the link for me, essentially, okay? And these variables here, where you see the squiggly lines, they're kind of special, okay? So I'll show you that now. But basically, we have a configuration built here for Selenium, which is going to undertake the actions for us, okay? So now what I can do in my model, if I take a look, okay, perhaps if I take a look at the click register link, and I double click on that, there's a bunch of properties associated with this block. If I go on the automation tab here, we'll see that there's a bunch of Selenium actions associated with this block, okay? So what we're going to say is, click register, I want this to call a bit of code in Selenium which is going to click the register link for me, right? So what we have here is the click register link, okay? And if I click edit on this, you'll see that it's calling that action which is in my configuration file, okay? So it's going to go away and map this to the Selenium code, and I'm just replacing this link CSS variable with some internal variable which represents the form. So this is like the map you were talking about earlier, right, where I'm mapping to user interface components. This is going to map to that click registration link. Okay, it's going to replace the variable in the code. Okay, so I've done this for all of the all of the process blocks here. So for all of the process blocks where there's a user action, I've added some automation code, which is going to allow the machine to run that operation for me. Okay. So now when I create my test cases, I've got 4 here. Okay, and what I can do is I can view the automation script associated with that particular route through the model. So basically what's happening here is I've got the model, okay, these have all got automation code assigned to each block. Okay, I'm creating a route through the model from start to end, and it's concatenating all of the automation snippets together to give me my one automation script for that particular test case. Okay. And on the right hand side here, you know, I can still view the manual test steps. So here I'm loading the web page and clicking login, and then clicking register, etc. Right. So what I've got, I've exported all of these. Okay. I just need to start up my Selenium web server. Okay, so I've exported all of these as a script. And if I go back here, okay, that's finished. Good. So what I can do is I can call Selenium to execute these scripts for me. Okay. Let's give that another go. Look here a second. See what's going on. Okay, I'm not sure what's going on there. But basically what I can do is I can go away and I can now run this script, and it's going to call Selenium and it's going to automate these actions for me on the web browser, right? Okay, so the real benefit of this comes in where, you know, I've formally defined this model, and there's probably, I don't know, maybe 30 process blocks on here that I've added. Okay, so what I can do is, as I showed you before, I can go through, I can extract all possible routes through the model. Okay, and instantly I've created 1,600 automation scripts, which I can then go away and run on this system, right? Okay. And now when something changes, so say, you know, I'm going to add a new field in here, or I'm going to delete an option. Okay, I'm just going to go in here and I'm going to change my model, right? So say for the registration now, perhaps I no longer want to find out their first name. Okay, I'm going to go in here and just delete all of the first name field. Go ahead and reconnect the model. I can go in here and I can now regenerate my test cases, or I can view my existing where it's saying, okay, these test cases were impacted by the change, right? And I can then go in and either delete or try to repair these test cases to fix them to the change that happened. Okay, I'm just going to delete these and go back. Right, so does anyone have any questions on that? Sorry the demo would have run, that's a bit annoying. It would have been really nice to have shown you that running so you could have actually seen what it does. But yeah, does anyone have any questions so far? Yeah, go ahead.
Yeah, but maybe I don't understand exactly what's happening, but isn't it just organizing better the scripts, basically?
Yeah, exactly. So basically, you know, we're familiar with kind of object-oriented programming, right? Where we kind of try and facilitate code reuse. Okay, so what we're trying to do is apply the same concepts to automation testing, where traditionally automation testing is just these, you know, scripts where it's just very linear, and then another linear script, and then another linear script. So we're trying to tie them together to make it more kind of object-oriented in a way. If that makes sense.
If you change something, like you had another text field in your login screen or whatever, you would have to write new scripts and stuff unless you've already written.
So I would have had to have done that before, but now all I have to do is update the model, right? So I would add in a new field here between these two process blocks, and then I would just regenerate my test cases, which would regenerate my automation scripts. So say I had, you know, the 1,000 test cases associated to this before. If I'd made that change previously, I would have had to have gone through each automation script file, right? So I would have had to have gone through 1,000 files to check if they were impacted by this change. Now all I have to do is the model is my kind of focal point, where I just have to update the model to that change, associate some code snippets which, you know, do whatever that new feature is, and then I just update, you know, I just regenerate the test cases.
The testing doesn't change, it's just organizational.
It's just organization, exactly. So this is kind of, you know, you still end up, the end goal is still the same, you still end up with all of your 1,000 automation scripts. This is just kind of like something which sits in between, which facilitates you in getting to that end goal quicker and more efficiently and more adaptable to change, right?
But it seems to me the other key thing, well, there are two other key things happening.
Mm-hmm.
Like if you, in the traditional sort of writing a script that does the testing automatically, you miss a lot of the different configurations. You don't traverse the whole decision tree if you're doing it in a traditional fashion. You just miss a bunch of paths.
Exactly.
That's what happens.
So I kind of skipped over this slide, but basically, wherever this has gone. So yeah, most testing is kind of, you know, random. So there's no kind of methodology behind how we generate the test cases. A lot of the time you speak to testers and you say, well, how have you tested this system? And they kind of come back and say, well, I've just come up with the number of test cases that, you know, my testing manager wanted me to generate. There's no kind of concept of coverage or how much, you know, have the combinations of user interaction have I tested. Okay, no one's aware of this, right? So coverage, you know, with model-based testing, you get this kind of concept of coverage, is structured, is accurate, etc., right? And just kind of to go through, so most testing is not thorough enough. It can't be measured. Often it can't keep up with change, and it's very slow as well because it's mostly manual testing, right? So yeah, you're exactly right.
The other thing I see happening too is you get a visualization of your testing space.
Mm-hmm.
So with the traditional approach, that you can't see the testing space at all. There is no such thing as a testing space, and this is adding a new space that was previously just not even acknowledged, as far as I can see.
I mean, the other thing is that finding when defects happen, they are expensive. Okay, so if you find a defect kind of after deployment, I think there was some study where it said it can cost up to $50,000 or something like that. So the earlier in the software development lifecycle you can find your defects. So if you find ambiguities in the software requirements, then the less kind of impact that's going to have further on down the line. So if I'm creating a visual representation of my requirements, then it's easier for someone else to look at this flowchart or this model and say, okay, does this actually make sense? Does this make sense that the system should be able to do this? And you can start to pick up kind of ambiguities in the system, in the requirements, which obviously then won't later propagate further down the development life cycle, right? Okay, are there any other questions? Otherwise I'm just going to Go ahead.
So I guess, I mean, in the quote real world, not for the successful companies, but for a lot of companies which are not successful, the user is the tester.
Yeah, exactly.
Right, it's just pushed out, and the users do the testing.
I mean, even the bad companies have testing divisions, but like they just you walk into these banks and they just don't know what they're talking about. They have no idea. They're just kind of everyone's haphazardly kind of taking a guess of how to test this, system which is looking after billions of dollars of investment funds. Right? There's no formal approach. No one knows what they're doing. They're just kind of, oh, let's try this and see if we can find a defect. Obviously that's not good enough in the real world, right?
So how do you convince a company to test their software in this sort of structured way?
The thing is that the testers who are lower down, so you've got this hierarchy, right, where you've got the testers at the bottom. A lot of the time they think they're doing a good job because, they want to keep their jobs. But basically, when you go up to that hierarchy and you talk to the other stakeholders, so the other people who are interested in those test cases, so you'll talk to the testing managers or the people above that, and they're very aware that they aren't testing the software well enough, because at the end of the day, it's their jobs on the line. If these defects go through into production, then someone's going to turn around and say, hey, I don't think you're doing a good enough job. So they're very much aware of this already, and they want to always improve the quality of the software they're developing.
So you don't find a resistance barrier to this
Not to the managers,
approach.
but to the underlying testers, yes.
Okay.
Sure.
How thorough is that software? As in, say if I had a web page which took a file or something like that, can you test files and etc. through the
Sure.
automation?
So anything kind of scripting based. So as long as I can create kind of a script, then I can just build a configuration for that, if that makes sense. So we've used that tool to create kind of CSV files, XML files, performance testing. There's a whole bunch of stuff. So anything which is language based, if there's a formal language behind it, we can build a configuration for that and then link that up to the model and create it. Right. Okay, good. So just to kind of conclude. Manual testing is very time consuming. Automation is definitely the future, but there's still many challenges in kind of creating effective automation frameworks. Model-based testing is kind of one of the proposed solutions to help with creating automation scripts in an agile environment, but there's still a lot of work to do in this kind of area to make it effective. So that's kind of it for the presentation. So one of the main reasons that I'm here today, as well as to help Bob out with the module, obviously, is we have a bunch of internship positions available within my team in CA. So if anyone's interested, we're paying £400 a week. We're based in Oxford. Just shoot me an email, James.Walker@ca.com, and just send us your CV. We'd be interested to hear from you. And that's over the summer, so it would be in between, your second and third years, basically.
Very nice. Yeah. Very nice. Nobody offered me an internship for £400 a week.
You can join now.
I have a question about the testing software. I mean, when you did the username and password example, I was very surprised to see almost 1,600 different path combinations. Mm-hmm. So you're showing kind of a kind of a trivial example.
Yeah.
So I'm guessing that when you do this on more complicated things, it gets it.
This is what I'm saying. You end up with trillions and billions of different combinations, right?
Yeah. So how do you manage all those different combinations? I guess you have to have a hierarchy of logic.
So this is where kind of coverage comes in, and we can create test cases based on specific types of coverage. So I can say, take my model. I want to cover all the process blocks in the flow, for instance, okay? So I'm going to create all the routes through here which just touch every block, okay? So you can easily see that this number is going to go down quite dramatically, right? In that example, I think there was 3 paths which you can generate, which is the minimal number of paths to touch every single process. And then you can go up in the order here, so I can say, I want to touch every single decision now, okay? Or I want to touch every combination of decisions. I want to touch all the possible pairs of decisions as well, right? So it's all about kind of finding the test cases for the maximal amount of coverage I can achieve, but obviously you're always constrained by the number of resources you have to execute those test cases, whether that be, you know, testers to execute the manual test cases or system resources to be able to execute millions of automation scripts, right? There's always some constraint on how many test cases I can run.
It would be fun to see this applied to a full system,
Mm-hmm.
because I know one of my first jobs, not Mick job, like my first quote, one of my first quote real jobs was to try to document the logic of a piece of software using flowcharts, and I was doing it manually.
So this is called business process modeling, okay? And actually this is a whole separate, different world of problems where a lot of the time you're going to banks and stuff and they're running these mainframe systems which are, you know, 40, 50 years old, okay? Most of our technology for banks is still running on mainframes. And a lot of the people who wrote that code are either retired, unfortunately they've died, or, you know, they don't exist anymore, right? They're not there to tell you how the system works. It's not documented in a way that people can read it. So you have this thing called technical debt, and technical debt is where you lose an understanding of the system, and that's probably what your job was, is trying to pay off that technical debt to try and recoup and understand how that system works.
That's exactly right.
And this is a whole different can of worms in that, you know, no one has any kind of process to try and understand that, and that's probably where, you know, a visualization approach would come in, right? Perhaps, or some kind of new approach to try and solve that.
Now I see why. So this was developed, was this implemented or developed at Grid Tools, and then CA saw this and thought, oh, this is good, we want to buy this?
So actually what happened is that we've got a whole separate tool which is all around kind of generating test data. So, you know, effectively generating billions of rows and populating databases, right? You can imagine for banks and stuff, this is a very difficult problem. You've got all these different relationships between data variables that you need to create and create proper distributions, right? So they were kind of interested in that software, and they bought that software. And so in the past year since the acquisition, I think we've sold this product for, I don't know what our exact revenue is, but it's in the tens of millions of dollars. Okay, so it's quite a big market, and it's growing at the moment as well. So they were wrong to give us a valuation of 0. But
to me, this is I'm really surprised actually. I've never seen anything like this before. Not that I'm in industry, and I used to be in industry, so I know about the problems and the old methodologies.
Yeah.
But I'm really surprised, and I would be very keen to try this out if I was in industry.
Yeah.
Very keen.
Cool.
Yeah.
Good.
Any other questions for James? Thank you, James. Nobody has any questions about the amazing internships that CA is
Well, my email was at the end anyway, James.Walker@ca.com, or just shoot Bob an email if you're interested.
So imagine I want an internship and it's £400 a week, which is very generous, but Oxford is one of the most expensive places to live, right? So where would a student live?
So yeah, we can help out with that. Basically, I did the internship scheme about 6 or 7 years ago, and I think Grid Tools arranged for me to, Grid Tools as it was then, arranged for me to stay with house share, basically. I think it ended up being about £60 or £70 a week, so it wasn't actually that expensive. It was quite
Nice. Very nice. Perfect. Cool.
reasonable.
Any questions about the internships? It's a good deal.
Do you know exactly what we would be doing for the internship?
So usually how it works is that we kind of would ask you what you're interested in, and then we would kind of give you a project based around that. So if you're interested in more data science kind of stuff, you could go away and do a project in data science, for instance. If you're interested in testing, you could go off and do a project in testing. Visualization, you could go off and do a project in visualization. We would just kind of leave you to it, well, not leave you to it, but you could go away and run with the project for 6 to 8 weeks. We would help you with that, and then we would just see what you end up with and, work from there. We don't have a structured way of working. It's very much kind of like do something you're interested in and we'll figure something out from it, if that makes sense.
Do you still work with Hugh? He's still around, so to speak?
Yeah, he's still around.
Good. So Hugh was the CEO of Grid Tools, the founder and CEO of Grid Tools, which was the company that was existing before they were acquired by CA, and Hugh said Hugh is a very special guy.
Yeah.
And he said something very special, which I still remember. He said it like 6 years ago, maybe, but I still remember. He was an invited speaker at Reconnect. Were you there at that one? And he said, when I hire somebody, I don't create a job description and then try to fit somebody into the job description. I hire somebody that I think is good and then write the job description to match their skills, interests, and personality. And I was just really surprised. I thought, wow, that is a really sort of modern, interesting, new, and refreshing way of thinking. Say, I'm going to design the job around the person rather than asking the person to fit the job description, which is really interesting.
Just to kind of put that in context, we've just hired an admin assistant about 2 months ago, and she started joining in and writing some code for the software as well, which is just,
unusual.
Really unusual, Really unusual.
Good. Any other questions, comments? So you're probably all excited about the prizes that CA is generously sponsoring. I guess you all figured it out, like who's getting third, second, and first prize. You could have figured it out, I guess. You didn't figure it out, like, ask around each other's scores, and then, like, okay. So the third prize team is the Thunder Dragons. Anybody from the Thunder Dragons here? Congratulations. We don't actually have a prize, a physical prize for the third place team. But it's very good for your CV. It's very good. The second place prize, does anybody want to take a guess? It's the team with the weird name, Scott Cheng. Anybody from Scott Cheng here? So you guys do actually have a prize. It's going to take some teamwork to distribute. It's £1 million voucher to Amazon. Congratulations. Says, who's the customer interface manager? Is the customer interface manager here? Anyway, maybe you can pass that down. It's going to take some teamwork to distribute that. And the first prize, which is £2 million voucher to Amazon, goes to the 5 cool guys. Congratulations, guys. So any questions about assignment 6 or anything like the meaning of life? We know everything. Okay, happy Friday and have a good weekend.
There we go. Any suggestions on